Okay, for this practice one, we are again starting at -5, going from the left-hand side. It looks like it's going down towards negative infinity. From the right-hand side, it's going up towards positive infinity. Those are not the same number, so the actual limit does not exist. And because there's a vertical asymptote going on here, this is undefined. At 0, we drop down. On the left-hand side, it's approaching -3. On the right-hand side, it looks like it's supposed to reach a height of 1. These are not the same number, so the actual limit does not exist. At f of 0, it actually is -3. As we approach 1 from the left, it looks like we're supposed to reach this height of 2. Same thing from the right. It looks like we're supposed to reach a height of 2. So the limit says that it will be 2. Now when we look at what the function actually equals at 1, there's really a point way up here, so the function actually equals 4 there. So that's kind of a tricky one and really showcases the difference between actual heights, which is what f of 1 is, and the intended height, which is what limits are doing. 4 from the left-hand side looks like it's approaching 3. From the right-hand side looks like -1. Those are not the same number, so the limit does not exist. And at 4, it actually is up here at 3. As x approaches negative infinity, it looks like the function is going up. That's this part of the graph right here, so we'll say positive infinity. And as we go towards positive infinity for the x values, it looks like it's approaching this height of -5. There we have it. Okay, for 2, we have this -3 from the left-hand side. It looks like we're approaching a height of -2. Same thing from the right-hand side. So the actual limit is -2, but our graph is undefined at -3 because there's a hole in the graph there. When we're looking at it as we approach 0, it looks like we're approaching a height of 1 from both sides. So it's going to be 1, 1, and then the real limit will also be 1. And because there's a nice filled-in point there, the actual function there is 1. At 2, from the left-hand side, we're approaching this height of -1. From the right-hand side, it's down at -4. Those are not the same number the last time I checked. And since they are both open circles here, this function is not defined as we can see on the graph. There could be a point way up there that's just not shown. At 6, it looks like we got a vertical asymptote. We're going down on the left and down on the right. So it's going to be negative infinity and negative infinity, which means that the actual limit is negative infinity. Just a reminder that those technically don't exist, but it's nicer for us to just say that they're negative infinity. And it's undefined. Now people sometimes have a hard time figuring out these limits, so I think this is a good time for us to take a break and look at this. So when I say look at the left and the right hand side, what I'm really doing here is hyper-focusing around this x value of 6. And then immediately on the left-hand side of this focus of 6, what's happening? It's going down. And on this side of 6, it's going down. So that's why both of these were negative infinity. If I do the same thing on 2 for these ones, if I look at this on just the left-hand side of it, so I could even scoot this over and just look at the left-hand side of 2, we can see that it's approaching this height of 1. Now, if I just look at the right-hand side of this, you would think it was approaching a height of 4 because we can't see this part. And that's really what I'm doing here. Each time that I'm looking at this from the left and the right, I'm kind of visualizing, okay, does the right-hand side does not exist versus the left-hand side does not exist, and that helps me fill out all of these different limits. Alrighty, we got -6 from the left and the right. It definitely looks like we're approaching a height of 1. So left and right are going to equal 1. If those are the same number, then the actual limit equals 1. However, the actual height is way up here at 3. As we approach -3, it looks like we got a vertical asymptote. From the left, it's going up towards positive infinity. From the right, it's going down towards negative infinity. Those are not the same, so we have does not exist. And this is undefined at -3 because we don't have any values defined there. 0 from the left is going to be -3. From the right is down here at -5. Those are not the same number, so this does not exist. The actual function is at -5. Do the same thing for 4. As we approach from the left, it's over here at -2. From the right-hand side, it's down at -4. Those are not the same number, and it actually equals -2. When we're looking at it going towards negative infinity, it's going up. As we look at it going towards positive infinity, it's approaching -7. All right, for this one, it's kind of difficult to see, but there's these markings over here that actually correlate to 1, 2, 3, 4. So that's what I'm going to use when I'm evaluating all of these. So as I look at, let's see, here's 1, 2, 3, 4, 5, 6, 7, 8. Everything was hard to see, my bad. So I'm looking at this x value of 2 from the left-hand side. It looks like it's way up here at 4. From the right-hand side, it's at 3. Those are not the same number, so this does not exist. It is filled in at 3, so f of 2 actually equals 3. When I'm looking at this at 4, on the left-hand side, it's at a height of 3. At the right-hand side, it's approaching a height of 2. Those aren't the same number, and it actually equals 3. For 6, from the left-hand side, it's approaching this height of 1. From the right-hand side, it's approaching a height of 1. So those are the same number, so the actual limit is 1. And because there's a nice filled-in point there, f of 6 actually equals 1 as well. Okay, for 5, this is a type that you typically don't enjoy. We're going to be given a whole bunch of things, and we need to try to sketch a possible graph. So I'm going to first group all of the things that have like x values together. So I'll begin with the as x approaches 1 from the left, as x approaches 1 from the right, and that the actual limit does not exist as we approach x equals 1. So this one's actually tricky, and we're going to spend more time with it next class. But when we have an x value approaching a number and the y values are going up towards positive and negative infinity, that actually indicates a vertical asymptote. So I actually know that there's a vertical asymptote as we approach x equals 1. And from the left-hand side, I'm going up, and from the right-hand side, it's going down. So 1 with the little minus sign means from the left, going towards positive infinity. 1 from the right with the little plus sign is going down towards negative infinity. The limit does not exist because those aren't the same number. Next, I will look at the x value of 4. Okay, so I'm going to start with the point that they gave us, which is g of 4 equals 1. And then they say that the actual limit equals 2. So that means from the left and the right-hand side, we need to equal 2, but I can't actually equal 2 because I know it already equals 1. So I just put little tails to signify that from the left and the right-hand side, we're approaching 2. We never actually reach it. As x goes towards positive infinity, we're approaching a y value of 4. So I'm just going to put a little dotted line here and then just say, like, put an arrow there to say, hey, I'm going that way towards 4. As I come on this side, negative infinity towards negative infinity, so I'm going down this way. So that's my rough sketch of everything, and all I have to do now is just connect the dots. So I always start from here and work my way over, connecting the tails basically. So this tail has to connect to that tail way up there. That's the next closest one. If I kind of follow what I did here, this is my next starting point. It needs to connect to here. If I follow this one needs to connect to here, and that goes on forever. And that's a rough idea of what this one looks like. Okay, so for this one, we're going to be finding the limits numerically, which basically means we're making a table of values, and it suggests we use our calculator to help us out. So here I have the calculator. In y equals, I've put this first function, 3x minus 2, and what I want to do is use the tables, but I need these specific values in it. So easiest way of doing that is to hit second table set and go down to this independent auto and switch it over to ask. So now when we go into the table, it doesn't automatically fill anything, and we can basically type in what we want. So I want to do 1.9, and hit enter, 1.99, enter, 1.999, enter, 2, 2.001, 2.01, and 2.1. You can see that it gives me all of those lovely y values. So here we go. I'm just filling them in on this side. So if I'm looking at this, it certainly looks like they're approaching 4, and we already learned that direct substitution will allow this to work. So since we could direct substitute, we knew that this was going to equal 4 anyway. So let's get the calculator set up to do the exact same thing. I'm just going to come in here and delete all of the ones that are already in here because I don't want these same values. And then I'll just put in a new function over here very carefully. Okay, so I'll do x divided by, I'm going to put parentheses, so the entire denominator is going to be covered here, and then it's x plus 1. Make sure I come out of the square root. If you have an older calculator, you probably need to put another parenthesis there, and then I'll put my closing parenthesis. I'm going to jump right into the table, and I have to do negative 0.1, negative 0.01, negative 0.001, 0. Whoops, that's a 1. My bad. Let's go up and delete that. I'm going to hit 0. There we go. I get an error. Interesting. 0.001, 0.01, and 0.1. So let me just fill in all of those over here real quick. So if I'm looking, On this side, they certainly look like we're getting closer and closer to 2, right? 1.9995, that's pretty close, and this is 2.0005. So I would say that even though we get this error at 0, the limit as x is approaching 0 is going to equal 2, because that's what the numbers on either side of it appear to be approaching. Now that you have the hang of it, let's just, I'm going to skip showing you it on the calculator, and I'm just going to enter in these numbers that I got from putting it in the calculator. So here we go. If I'm looking at positive 1 as I approach from the left-hand side, those look like they're approaching 2. Same thing from the right-hand side. They're getting lower and lower closer to 2. So even though we have an error at 1, the limit of this one is going to equal 2. Now this last one's a piecewise function, which is a little scary, but it basically says, hey, the y value equals 2 as long as x doesn't equal 3. Okay, so right here, x equals 2, all right, that's not 3, so then we're going to get 2 for all of these ones. Now when x does equal 3, we're going to have 0. So the limit as we're approaching 3, well, it certainly looks like it's supposed to be 2. So even though the actual height is 0, the left and the right hand side are both approaching 2, which means the limit itself is going to equal 2. Okay, for the finding limits algebraically, we're going to remember always start with direct substitution, then try factoring, least common denominator, and the conjugate method if that doesn't work. So here I try to plug in -3, I get 0 in the bottom, so I'm going to attempt to factor this. That's going to factor to, let's see, x minus 4, x plus 3 over x plus 3. Those are going to cancel, so I really have the limit as x approaches -3 of x minus 4. I can now direct substitute, so -3 minus 4 is going to be -7. Done. Here I try to direct substitute, I get 0 in the bottom, so I'm going to factor. The top has an x squared that can be factored out of it. The bottom has an x squared that can be factored out of it. Those x squareds cancel. What I'm left with, this x squared minus 7 over x plus 3, we can now direct substitute because we don't get 0 in the bottom. So I plug in 0 and I get -7/3. Done. Okay, for 3, try to substitute in 9. I'm going to get 3 minus the square root of 9. That gives me 0 in the denominator. So I'm going to attempt to do the conjugate method. So I'm going to do 3 plus the square root of x over 3 plus the square root of x. Remember, our hint here is that we leave the things that are not conjugates factored, so we don't actually simplify them. And then here I'm going to get 3 times 3, that's 9, and a minus x. These are opposites of each other, so when I cancel them, I'm left with an extra negative sign, so I really have a -3 plus the square root of x, and I'm doing the limit as x approaches 9. I can now direct substitute. I get -3 plus the square root of 9, so this is going to be -6. So for this one, if I plug in -1, I get 1 plus 1 minus 2, so that's going to give me 0. So I'll try factoring. Top factors to x plus 1, x minus 1. Bottom is going to factor to x minus 2, x plus 1. So x plus 1's cancel, so I'm left with x minus 1 over x minus 2. That's what the limit we're now evaluating. If I direct substitute into this, I get -2 on top and -3 on bottom, so that's 2/3, and that is the answer. Okay, 5, I try to direct substitute. I'm going to get 1 minus 1 in the bottom, so that's not going to work out too well for us. So I'm going to multiply by this really annoying conjugate. Square root of 1 plus 3x plus 1 over the square root of 1 plus 3x plus 1. I will not distribute on the top, so I'll just leave it the way it is. And on the bottom, I'm going to get 1 plus 3x minus 1, okay? So if I simplify this stuff down, this the minus 1 and the plus 1 cancel, and the x are going to cancel out. So I'm really left with 1 plus 3x under the square root plus 1 all over 3. Limit as x approaches 0. So I can direct substitute. I'm going to get the square root of 1 plus 1 over 3, so that's 2/3. Over here, if I try to direct substitute, I'm going to end up with 8 minus 8 over 4 plus 2, so that's 0 over 6, which is 0. So this works. It's only when the bottom equals 0 that we can't direct substitute. 7, we try direct substitution. We're going to get 1 minus 3 plus 2, so that's 0 in the denominator. So next I will try factoring. I'm going to get x plus 2, x minus 1 on top, and then I'm going to get x minus 2, x minus 1. So the x minus 1's cancel. I'm left with x plus 2 over x minus 2, the limit as x approaches 1. Substitute in 1, I'll get 3 over -1, so this is going to be -3. Try to direct substitute in for this one. Not going to work out too well for us, so I will multiply top and bottom by the conjugate, so square root of x plus 3. On the top, I'm not going to actually distribute these through, but I am going to factor the x squared minus 81. So I'll get x plus 9, x minus 9 times the square root of x plus 3. And on the bottom, I'm going to get x minus 9. So that's going to cancel out that term. So I'm left with the x plus 9 times the square root of x plus 3. And our limit as x approaches 9. Let's direct substitute. I will get 18 times square root of 9 plus 3, that's going to be 6. So 18 times 6 is 108. So that's what this limit is. Okay, we try to direct substitute. We get 0 in the denominator for both of these ones. So what I'm going to try to do is first combine these into one fraction to see if that will help me simplify things. So this factors to x plus 1, x minus 1. So this one over here needs an x plus 1 top and bottom in order to have the same denominator. So now if I simplify, I have x plus 1 minus 2, so that's really an x minus 1. And on bottom, I have x minus 1, x plus 1. So I can cancel out the x minus 1s. I'm really going to be evaluating the limit as x approaches 1 of 1 over x plus 1, which is going to be 1 over 2. Over here, we get x minus 2, we plug in 0, we plug in 2, we're going to get 0. So I'm going to try factoring the top. That's going to be x squared plus 4 times x squared minus 4 all over x minus 2. That didn't help us yet. So next I will just factor more. So I'm going to get x squared plus 4. When it's a plus sign, we can't go any further, remember. But with the minus, difference of perfect squares, I get that. Now that I've canceled that out, we can evaluate the limit as x approaches 2. We'll just direct substitute in. So I'm going to get 2 squared plus 4. That's going to be 8. And 2 plus 2, that's 4. Those guys canceled, so I'm left with 32. Ta-da! 11, try to direct substitute. We get 0 in the bottom. I'm going to do the conjugate method here, so I'm going to do square root of 2 minus t plus the square root of 2. This is a lot of t's and 2's and plus signs. It's going to get a little confusing, but I will FOIL up top. I'm going to get 2 minus t minus 2 all over t, and I will leave the bottom part undistributed here. Okay, so up top, the 2 minus 2's are going to cancel each other out. And then I get minus t over t, so that's going to be a minus 1 over the square root of 2 minus t plus the square root of 2. And we're doing the limit as t approaches 0. So now that we've eliminated that t right there, we can direct substitute. And I will get negative 1 over the square root of 2 plus the square root of 2. So that is going to be 2 rad 2. We could rationalize this if we want to. I'm not going to bother. 12, we go to direct substitute, 0 in the bottom, so I'm going to factor out what I can. The top can factor out a 2h, so I'm going to be left with h minus 4 over the 6h. Let's simplify this. We get h minus 4 over 3, limit as h is approaching 0. I can direct substitute, and I get negative 4 thirds. 13, I try direct substitution, I get 0 in the bottom, so I'm going to multiply top and bottom by the conjugate of this, so that's going to be x plus 3x minus 2. Plus 3x minus 2. And let's see, I will distribute on top. That's going to give me x squared minus a 3x minus 2. It's important with that parentheses there. And on the bottom, I will factor the x squared minus 4 to give me x plus 2x minus 2. And I will leave the rest of it alone. That's a minus sign. Up top, when I distribute this through, I'm going to get x squared minus 3x plus 2. So that's going to factor to x minus 2, x minus 1. Which will cancel with my x minus 2 in the denominator, which is going to allow me to direct substitute now, I believe. So let's see, that's x minus 1 over x plus 2 times x plus the square root of 3x minus 2. And I'm doing the limit as x approaches 2. So up top, I'm going to get a 1. Here I will get 4. And here I'm going to get 2 plus, let's see, what is this going to be? Math is hard. 6 minus 2 is 4, square root of 4 is 2, so I get 2 plus 2. So 1 over 4 times 4 is going to be 1/16, so that's what this limit is equal to. Over here, try direct substitution, doesn't work. I'm going to multiply by the conjugate. I will factor out the 6 on top to get x minus 1, and I will not distribute this through. On the bottom, I will, though. I'll get 1 minus x. These guys are opposite, so they cancel to be negative 1. So I get negative 6, 1 plus the square root of x, and that's what I'm going to be evaluating as x approaches 1. So that's negative 6 times 1 plus 1, and that's negative 12. All right, for 15 here, try direct substitution. We get 0 in the denominator. I'm going to multiply by the conjugate, so square root of all that stuff plus 2 instead of minus 2. On top, I will get 6 minus x minus 4 all over, and I will just factor the x squared minus 4. It's going to give me x plus 2, x minus 2, and then I have that square root 6 minus x plus 2. So this stuff up top, it reduces down to 2 minus x. So I'm going to cancel it with the x minus 2, and it will give me a negative. So I'll have a negative 1 over x plus 2 times 6 minus square root of 6 minus x plus 2, the limit as x is approaching 2. So I can direct substitute now. I'll get negative 1 over 4. Let's see, this is going to be 2 plus 2 is going to also be 4. So I'm going to get a negative 1/16 for this one. Over here, I'm not going to attempt to plug in the 4. I'm just going to basically assume that this is going to be a one where I need to factor. And even if I don't, it's going to at least make it easier for me to substitute in 4 later. So I'm not doing all of this extra crazy math down here. So up top, I can see that I can factor out a 3, and I'll be left with t squared minus 16. So that's going to give me 3t plus 4, t minus 4. On the denominator, I'm going to get 2t, t, and let's see, I need to get to 24 and add to 11, so that's going to be 8 and 3 ultimately, right? So I need 2 times 4 and a 3, and I need them to be, let's see, both negative, right? Yeah, there we go. So these guys cancel, so I'm really left with a 3t plus 4 over 2t minus 3, limit as t approaches 4. And I can direct substitute now, so I'm going to get up top 3 times 8, and on bottom I will get 8 minus 3, so that's 5. So I end up with 24 over 5. That was the longest practice section in the history of practice sections. Until the next one.